Hey guys, welcome back. If you haven't seen part one, check out the card in the top right. Now, I'm recording this directly after, so if you have given me feedback about, I don't know, maybe like the font size is too small or something about the audio, then unfortunately, obviously, I haven't heard it yet, so it's going to be essentially the same as the first video. Although, this is about as large as I can make the font size without cutting things off. Of course, that's because I'm using both of the files side by side, which I think something like 70% of you said I should do. So in this episode, we're actually going to make at least the components that we need for the lexer to work. We might also get to the lexer itself. So I think the first thing we should probably do is just the debug file. It's pretty simple. In the just C package, we can just make a new file and call it debugfile.kt. Similarly, we can say this is in the C package as well. We'll need, from Java, we'll need to import file from java.io.file. And now we can make a data class. What a data class is in Kotlin, it's very similar to a class. It just does a handful of things by itself that optimizes it for essentially just holding information. If you're very curious about the specific things it does, you should probably look it up. I don't think, I'm pretty sure we could do this the same way as a class. Essentially, the big thing is these arguments that we're passing in are going to become properties, and we're this is essentially equivalent to making a basic constructor for a class, which will take these three values because we don't want them to change ever. It doesn't really matter, but it's for the best. I'm formatting them this way just so they don't go wider than 80 characters. I don't need that second one. And then we can actually do the class. Similarly, it's going to have a source path and an out directory and options, but that isn't where the debug file is. Also, I just said debug file. So it's going to need an actual path for where the debug file itself is, and we're also going to need an enabled. So this is a property, right? When I say val path of type string, this is like a property that you can access by saying, if you have an instance of a debug file object, you can say .path, and this will get the path property from that file, which will just return the string. But something we do often in programming, at least in Java programming, we sort of nest properties. We keep properties private, and we only access them using getters and setters. Of course, in Java, this is a huge nightmare because you have a huge file or a huge function definition per each property, which is a huge issue. So in Kotlin, we can use what are called fields, and this works exactly the same way as a property, but it actually calls a getter function. A lot of people like to format it on a new line. I like to do this if I can, so that they're on the same line, so that I don't need new lines between the properties. You can format it how you want, but basically we're defining a getter, which is going to give the value of it's going to give the value that enabled is at that point in time. But the good thing about this is it can change. Now, actually, in this case, we really don't need to make this a field, because at this point, I don't think we do anyway. We should be able to just set this equal to D in options. And that should be fine, because when it's constructed, we'll be passing it the options, and then after that, during construction, we can just say this. If it doesn't end up working, we can use the field thing that we have on the right. In Kotlin, a lot of the class things are weird, so it's sort of it's a lot more procedural the way that the construction of an object happens in Kotlin. So you notice it says property must be initialized or be abstract. That's because we haven't provided a value for this a value for this val, which cannot be reassigned, which makes no sense. So either we have to make this abstract or provide a value here, or what we can do is make an init block, and init is going to run at construction. It's going to run, I believe, in this order. So after those properties sort of exist, we can then come in here and assign it. And I guess this technically, the reason I used an init before was because the getting the path string was a lot more complicated, but now that I have it in one big disgusting line, I can actually just come up here and do it. So where are we going to put this fat path, right? That's the question. Where do we want the debug file? Well, we want it to be next to the output file. Or we essentially want it in the output directory, and we want to have the same name as the source file, but we want to append debug at the end, because that's how I choose to name it. You can name it whatever you like. So for example, the path is going to be the out directory, followed by, we need the actual, like, name of the file. So what we do is we create a file. This is just going to make a file object. It's not actually going to, like, do anything. And we want the source path, followed by debug. And then we make that file, which is the source path and debug, and then we call get name to get rid of all of the rest of the properties, because source path might be something like /home/ something else, but suppose it's /home/test/ file.c. When we call file.name there, that's just going to give us file.c. Like, that's all we want, because we just want that name, and we want it in the output directory, which is why we're doing it this way. And you notice something cool about Kotlin's string interpolation here. We can just put a string inside of this, and it doesn't even care. We don't have to escape the quotes like we would in a Python F string or anything. It just works, like, recursively, and I really like that. So hopefully you understand this line. You, of course, can call it something different, but this is just going to take the source name, append debug onto the file extension, and put it in the output directory. And then we still need the init, and what we want to say is if it's enabled, then there's two things we have to do. If this file, this debug file, doesn't exist, we need to create it, which we actually don't have to do that here, but suppose we've already run the compiler, and this debug file exists. Well, we don't want to append to it, which is the default behavior. We want to actually we want to blank out whatever's in this file. So we can make the file, and then we can just say write text. And we can start with source path to just sort of say, like, this is the file that we're debugging. And then this will happen at construction. And then we can just have a simple write, which I'm going to do sort of like the print statement in Python, where we take in a string and we take in an end. And the end, in Kotlin, of course, you can use default arguments, which are beautiful. And by default, I'm going to have 2 new lines just for spacing. We'll see how that looks in a moment. And basically all this write is going to do is, well, if this debug is enabled, which is why we have our option, because most of the time you're probably not going to want to have to print out a debug file. That's really dumb. But for our purposes, we're pretty much always going to do it. But this allows you to not do it and allows your users to do it if they want. And so we can make this file, and if debug isn't enabled, when we call write, it's just going to do nothing. So if it is enabled, then we have to make the file, and we can append to it. And we can just append the string followed by the end. And that's it. We don't have to, like, manage the file or anything, because the way it works is it essentially just makes it each time. You don't really need to keep track of the lifetime of the file. Hypothetically, it's slightly worse performance, but it's also more safe. I think if we go back now to app.kt, if we go into compile file, we can now make our debug file as well. I'm just going to call it a D file. And we can create a new debug file using our source path, out directory, and options. And then we'll run the lexer and whatever. And in run lexer, what we are eventually going to do is we're going to actually write out all of our tokens, but for now we can just say dfile.write. And again, if the user never entered the D into the actual, like, options, then this is going to do nothing, but we always have it toggled on. we can just, oh my god, I can't type. Tokens, a little bit of formatting, and then nothing for now. DFile. Right. So we actually have to pass in the DFile. And we'll have to do that up here as well. And then after, we'll get rid of the faults, and we'll pass in the lexer, which itself will contain the faults. So let's now see. We rerun this, build it, run it. Now it's not complaining anymore. The output here, our program is outputting this. It's building name of file here, which I could change, but I'd have to pass in the source path. The source path is going to be stored in the lexer object eventually. So, like you see here, lexer.file.path. So I'm not going to worry about that yet, but basically, we're building a file, and when we're done, it will make this debug file. And actually, let's just quickly check this out. It would be, I think I have to actually back out, go up, and it should be in test, and now we have our file.c, which is empty. Nope, that's the other one. This, and we have this file. And you see the formatting that we have with all the new lines. It says which file it's generated from, and it will give all the information that we want, like tokens and abstract syntax tree and stuff. Now we can head back the slowest way possible in Vim, because I'm not good at it. Nice. Now what we want is this. We can come in here and we can make a new directory, and let's call it lexer or tokenizer, whatever you feel whatever you want. Now we have 4 things we're going to need, and the best order is we'll start with the source line, because everything it grows in dependence. The lexer requires tokens. Tokens require, well, the lexer requires the source file and tokens. Tokens require SourceLine, and SourceFile requires SourceLine. So SourceLine's the foundation. Then we can do the file, and then token, and then lexer. So let's make sourcefile.kt, and sourceline.kt, I mean. It's always that same line and that I keep pasting. Okay, package c.lexer. And again, we'll make a data class, and we'll call it a source line. And like I said before, what the source line is going to do is we're going to store each line of the source file as a source line object. So it's going to need a line number. I'm just calling it num because to me, it's implied that it's a line number by being part of the source line. And it's going to have some text, which is a string. You could, in another language, make this an unsigned int, probably. In Kotlin and Java, there are only there's only signed ints. And also notice that if you're familiar with Java, Kotlin doesn't have the integer Boolean primitives. You're just using the container class, which isn't really a big deal, but it makes things sort of convenient. Plus, I do really like, just as an aside, I really like when types are all capital initially. Because it just, that uniformity makes things really obvious. It's like, if it just starts with a capital, it's like, okay, that's just going to be a type, no matter what. And if it's lowercase, it's a value. I really like that. So, we can make another mini class called a position inside of the source class. And this is going to represent a position in the line. Now, you could just use a pair to do this, but I prefer to do it this way so that I have the default arguments in the constructor, basically. And you'll see what I mean in a moment. A position has a start, which is just a single integer, which is by default 0. And it has an end, which is another integer and 0. And that's the whole class. That's all that position class is. It's a start and an end, and everything that's between those values is in the position. And we can now keep track of a position as we sort of do things. But it should be private because this should just be a part of the source line. And then we can also add a helpful field called unread text. So basically what we're doing, as we go through the source file, we'll be going through each of the lines as well. We'll be going character by character in the lines. we can keep this private position to keep track of where we currently are. This is sort of like a lexer component that we're baking into each line. And I'm choosing to do that instead of keeping the position part of the lexer because I just think it makes the code simpler overall. But conceptually, it should be part of the lexer, I suppose. And so similarly, as we move our position, we're going to have less and less text in the line that has not been read yet. So we can, in order to know which parts of the line have not been read, we can make a field called unread text, and that will just return the rest of the string. And how we do that is we can just say it is the substring created from the end of our position forward. And because this is a field using a get function, that's going to change the value of the unread text quote-unquote property every single time we use it if position.end has changed. And publicly now, we can create a list of marks because like we said before, we're going to mark positions in this line where errors have occurred or warnings or failures have occurred for our fault system. So marks is going to be a list of positions. That's all it is. And then we'll be able to use those positions to know how to generate all those carets that we saw in the last episode. We can also have another useful field, which is just at end, to know if we've reached the end of the line. And how we can define this is just, it can just be, is the unread text empty, right? Because text.substring, if we're at the end here with this position, then it's just going to be empty, and there won't be any text. Then we can have a nextChar field, which is going to be the next character in our process of reading, like based on our current position, what's the next character? And if we're not at the end, it should take the unread text at 0. Otherwise, we want it to just be a null character. It could be kind of anything, but I'm choosing to be a null character. In this case, we're using like the Unicode 4-character hexadecimal representation, but it's essentially the exact same as /0. It's just Kotlin doesn't support /0, so we use the Unicode representation of it, which isn't a big deal. But yeah, so we have to check if we're at the end or not, because we're taking the first character, the next one, right? The first unread character here. Otherwise, if we are at the end, then there is no first character, and this is a problem, which is why we're simply returning a null character to represent that we're at the end. Now, I've also found it very useful to create a next string function, and this is going to take a number of characters, and essentially all this is instead of doing a single character to know what's next, we can see which characters, plural, n of them are next, and that can be useful sometimes for certain checks. And what we can do is we can just take our unread text, and we can take n. And what this means is string.take is just going to return the first n characters. It's going to make a string. It's essentially the same as the substring, but it's just the substring of the first n characters of it. Then there's some other useful stuff like ignore position. Sometimes we're going to be reading characters that don't matter, and we don't want to save those. Because essentially, let me go into a bit more depth about how this position system works. Instead of keeping track of the position of each token yourself, the source line's always keeping track of its own position based on the lexer, and the lexer can move that position and stuff. So as you sort of take in characters, this position's going to grow, and it's going to be like 3, it's going to be like 3 to 5, 3 to 7, etc. And so every single time you read a character, that position will grow. But sometimes you read characters that you don't want to be a part of the next token. So what you have to do is you have to ignore the current position, which is going to simply set the start of the position to the current end. And so when you then continue to take characters for the next token, they won't include the previous ones that you actually didn't want. For example, spaces. We'll be using this to get rid of spaces and comments. Then we can have a mark position. And this is going to actually be how our mark works. It takes in a position, and we're just going to add to our marks the position. And we'll worry about that in a moment, what that's actually going to do. And then we can also step the position. Like I said, we can move it. If position end is less than the length of the line text, because just to make sure that all of our stuff keeps working when we call like substring, for example, for unread text, let's stop incrementing once we've reached the end, just to make sure. Position m plus equals 1. You can do plus plus, of course. I'll explain it more later when I get into what exact features of the language we're introducing, but I personally prefer to be more explicit. So yeah, now we'll be able to step the position, which if we're not at the end, we just increment the end of the position. So then what we want are two functions, so that every time we make a token, it can give that token the position that it's been working with, and it can give it the string that is represented by that position. So we can make like new position. It's not the best name, I think, considering I have like, well, new string and next string is kind of weird, but new position will return the current position. Val position is equal to position.copy. We want to copy it because we're going to modify it later. So if every token's pointing to the same object, that's not good, right? They need their own object. So we're going to copy the position at its current state. Copy is one of those useful things that you get by making it a data class, I think. So we want to take that position, which is a copy. We then want to quote unquote ignore position. All we're doing is we're shifting the start equal to the end, but you know, we're ignoring it. And then we just return that position that we saved. And similarly, we can have a new string, which will, first it needs the position that we just created. And it will just return the substring from position.start to position.end. Could I put this all on one line? Probably a bad idea. Okay. Let me write this, and then if we come over here, we have this one big error handler thing called getMarkedLine. If you remember, in the faults.component class, we have a component interface. We have a getMarkedLines, plural. The reason for that is when we're dealing with nodes will often span multiple lines. So for the general thing, it's going to be that. But essentially what that's going to do is each node, if it keeps track of multiple lines through the tokens will be able to call getMarkedLine, and then the node will compile a bunch of lines in order to like make it work. So for a single line, we have a getMarkedLine, which will return a string. And this is where we're actually going to do our like error handling. First things first, what we have to do is we have a list of marks, a list of positions. What I'm going to do is I'm essentially just going to take, if we have like 3, 4 is marked and 4, 8 is marked, or actually if like this, right? 3, 4 is marked, 5, 8 is marked. Essentially 3 to 8 is marked. So that's all I care about. I don't care about the things in between. If you mark those things, basically from the start to the end. So we need to figure out where those start and end points are. So we can loop through each of the positions that are marked. And if start is -1, meaning we haven't assigned a value, or if the position that we're looking at, if its start is smaller than the one we're currently storing, we can just store this. You should recognize this as like a generic min function. It's like a very simple algorithm to find the minimum of a set of things. You just check if it's less than the minimum you have, and then you assign it if it is. Since these positions will never be negative, I'm using negative as a default value so that no matter what the first one is, it will always work. We can just check that. Same thing here, if end is -1, meaning we haven't actually looked for one yet, or if the end we're looking at is larger than the end, we can assign it. And this is a generic like max. So now we have the positions from the start to the end that are marked in totality. And suppose that the line is empty, right? Suppose that this line is actually completely empty. Well, sometimes we run into errors at the end of file character. And if the text is empty, we're not going to have a good error because things are just going to be weird because it's not going to line up and stuff. So I have a specific case for when we're at the end of the file, and that's this. We can return. And this string interpolation, one flaw with it, for example, if I had a variable x and I did this, you can't format things that way. But what you can do in Kotlin is you can do this and .format on a string. So the way I'm getting around this is I'm still using the string interpolation, but I'm also using the format. So I just want it to be 4. I want the number to be 4 characters wide, because I think 4 is reasonable. Like, if you have more than 9,999 lines in a source code file, you're probably doing something wrong. So if it formats badly, that's on you, not me, you know? So we just format the number, the line number, this way so that there's 4. It also needs to be a %, of course. And then we paste that in using string interpolation. And then I want the explicit text end of file. I want to put 4 spaces. I would use a tab, but sometimes in certain terminals it will display 8 spaces instead, so I'd rather explicitly just do 1, 2, 3, 4. And then the reason for these 4 is to match up with the 4 that are formatted. And then 1, 2, 3 to point to E, O, and F as like a problem. And now that's just the one case where the error is on the end of file. So this will produce something like, it would look kind of like, it would essentially be, suppose it's line 2. The way that this would end up looking is it would be 1, 2, 3, 2. And then 1, 2, 3, 4, line, doot. That's how it would print out. And again, I'm using the %4 so that if you have 2 digits or 3 digits, it will align evenly. But of course, I think 4 is like the reasonable amount. Like maybe you could have 1,000 lines and be reasonable, but getting to 5 digits, it's like no, just no. So I think 4 is a good sort of formatting choice. Now I can make now you see here, this is what I'm calling the marker string. When we have the end of file, we have just a finite number, but we need to put a marker under each of the marked characters. So what we can do is for I in text.indices, this is equivalent to doing a for loop for like I is 0 up to the length of text, I++. We're just taking text, and dot indices is going to return like a range of the indices, and we're going to loop through that from I0 up to the maximum one. And we're going to now append to our markers. If the index we're dealing with is inside of our position that we've figured out, right, between the start and the end, meaning it's less than the start, and it's greater than or equal to the end. Well, actually, this means this is the negation of that. It's less than the start, or it's greater than or equal to the end, meaning it's not in our position. Then we add a space. Otherwise, we add our caret. And you can use whatever symbol you like. Some people might use these symbols or, you know, whatever you want. But I think the caret's a reasonable one. It looks pretty fine. And now we can simply return essentially the same thing we had before, but general this time. We need our %4d.formatNum. And then this time we have whatever the text is, followed by... Okay, so notice each of these lines is going to end in a new line. If it's not like an empty line, it will end in a new line. There might be some issues where you have text right at the end of file, but if we run into errors, we'll just have to solve those later. But for most cases, the text will, every line should end in a new line, and we can try and guarantee that. 1, 2, 3, 4. And we can then print the markers on the next line with the 4 indented spaces and stuff. I don't have a good way to... The big issue with this is it's hard to demonstrate this. I can't really demonstrate this without a component to sort of show. I mean, I guess I can. Maybe we can do something. If I go back to app.kt, now I actually have to, well, temporarily, you don't have to follow this part. I just want to do it to sort of showcase. c.lexer. So we're already doing this. This is something that's going to be ran. So let's say val line is equal to a new source line, and it's line 5, and the text it contains is this is a line. And I want to now say val position is a source line dot position. And let's do the characters from like 3 to 7. And we can say line dot mark the position. And then we can print out line dot get marked line. Unresolved reference source line. Because I didn't actually finish this. That's why I wasn't getting recommendations as well. Oh, right, mark position. Because I want to be a bit more verbose. So now if we do this, let's see what happens. It's mostly working. This is a line. Right, because like I said, that's what happens if your text doesn't end in a new line by itself. But when we make these lines from our file, they will always. Nope. Here. And this is essentially what it would look like. And we marked from, what, 3 to 7? So, what, 0, 1, 2, 3, 4, 5, 6. And so it's not including the 7, which I think that's exactly how I'm doing it, because it's just the way that the positions are kept track of. So suppose we want to specify it's the is. Then we just need to do 5 to 7 instead. And this is probably a bit more representative of what it would end up looking like. Suppose the is a problem, it would look like that. And I think that's a reasonable way to represent errors. It's like a pretty good way. There's a lot of stuff you can do using this system. I can get rid of all that because that was just a test. I gotta say, talking for this long's like very interesting. I'm definitely putting a lot of information into this. Okay, source file. This is where we're actually going to construct our lines. And we're going to keep track of the actual file here. So let me go back, go into lexer, and we'll make a new file. SourceFile.kt. Again, it's going to be package c.lexer. We need the file from Java.io as well. And I also want to use a buffered renderer. Buffered reader. This will just hopefully make this a bit more efficient. I'll explain in a moment what it's doing. We want another data class called SourceFile. Oh my god. And it just has a path, which is a string. Now what I want to do, private val, I'm just going to call it file, but it's actually a buffered reader. And you have a few ways of dealing with files in Kotlin. You can use a file like this, and you can do like get lines or something, and you can read the whole thing at once and store it. But what I want to do is I want to get a buffered reader, because what a buffered reader will do is it will read part of the file, store it into a buffer, and then you can read from it, and then it can either directly read from the file when you want to, or it can like read it in chunks. because what we're going to do is we're just going to read this line by line. We don't need every line of the file in memory at once, which is good because if we're doing this asynchronously and we have 1,000 files compiling in different threads, we don't want all 1,000 files completely in memory at the exact same time. That seems really dumb. So what I'm trying to do is, if I understand this correctly, by using the buffered reader, we'll just have parts of the file at once. Although, since we're storing the source line, it kind of is going to end up being the same thing anyway, but if we have to worry about that type of optimization, we will later. So we have this buffered reader, and we have like a line num so that we can keep track of how far we are. I thought that ended up not working, but I guess it did. We want a late init variable. So you saw before, it said like this thing doesn't have a value. Let's actually just see exactly what it says. Property must be initialized or be abstract. By declaring it late init, we're saying this is it's late to be initialized. It will be initialized later. If it isn't, you'll get an error, but we're planning to. So next, let's make another property before we ever initialize line. Similar to our line, we'll have a SourceFile.atEnd to know if we're at the end of the source file. And if we are, we'll be at the end of the source file if the text of our current line is empty, which represents an end of file. Now, before I had next care, but we're going to directly interact with the file in the lexer. So I'm just going to say next. And this is essentially just going to be line.nextchar. Because I don't want to have to say file.line.nextchar all the time. I'd rather just say file.next. Because that's just going to make our code a lot better in terms of readability. So at our compiler, we actually have to call setLine, which we haven't implemented yet. And this is going to initialize our line. Let's scroll down now. Let's implement that setLine. It's a private function. I'm not like being super explicit with my like public private sort of declarations. A lot of the things I have as public really don't need to be, which is it's because I designed this in Python, and so I didn't have to worry about it then, so I just haven't really thought much about it. I've made some things private, as you can see, but it really like doesn't matter in like at all. Like it just doesn't matter. So when we set our line, we're going to make a new source line with the current line num, and you can do ++ here. Like I said, I prefer to not. And what we can do is we can use this buffered reader that we're calling file, and we can say read line. And this is a like Java thing, so it's going to return a string, and that string could be null. So we're going to use this syntax to access the string only if it isn't null. If it's null, then this access whole thing will return null. And we'll worry about that condition later. But suppose it doesn't return null, then what we can do is say .plus, which is just adding. We can append to it a new line. That's how we're getting the new line on every single line. We're just adding it directly. Because when we read it, the buffered reader is just going to throw it away. We'll add it back. So now there's two options here. If readLine returned a string, then we have the string appended with the new line, or we have null. We can now use the null coalescing operator to say, if the thing on the take the thing on the left, if it isn't null, and if it is null, take the thing on the right. That it looks like a ternary in other languages because it essentially is. Like you could say x, it's equivalent to this really, where this condition is x equals null. It's like exactly that, but it's just a shorthand. So either if it doesn't read a thing, it's because we're like at the end, so it's empty. And then we'll know we're at the end because of our @end field. Otherwise, we have a line that now has a string. And of course, we need to increment our line number. We go back up here. We also want a next string, just like we did in our line with our n as an int. And it's just going to pass that because I don't want to have to reference file.line, I'd rather just say file.nextString. Now we can then do another function called readLine, and this is going to call setLine. All we have to check is if we're not at the end, then we set the line to change the next one, essentially. We're just reading the file line by line, and we'll set the next line. And notice we're not keeping track of the previous lines, but every token will have a reference to the line that it's in. So the objects will exist in memory through the tokens if they're used. Hypothetically, if they're not used, then they're just tossed away because they don't need to be used. Now we get to the meat of this source file object or class. It's the take function. So what we'll be able to do in our lexers, we can just check, like if file.next is a certain character, we can do stuff. Or if the next string of 2 characters is something, we can do stuff. And the thing we can do is we can take from it. We can take those characters and keep them stored in our line, and we can actually like increment our position that we've set up. So this is where default arguments really shine, because I can give a lot of options, but I can use a handful at a time. So the first argument of take is num, which is how many characters are we taking. The default is -1, which means it will just take infinitely. Now, my implementation of take is going to take up to the end of the line. You could implement it so it just takes until the end of the file, but I'm doing it line by line. So -1 will essentially read all the way through the entire line. These is a string, and it's a list of characters that you want. So if you say take these equals the digits 0 to 9, then it will take characters until they're not in that list of characters. And there's also an until that I have, which again, I'm defaulting these to empty strings so that they just don't mean anything. If you don't use the argument, it doesn't matter. But what until does is, it's very similar to these. If you reach a character that is in until, you just stop taking. And so there's just 3 sort of conditions you can use to take symbols from the file. So if you try and take and you're at the end of the file, or you take 0 characters for some reason, then you should just return an empty string, right? If you take 0 characters, you should do nothing. If the file's actually ended, you should do nothing as well. Otherwise, we want to construct a string of tokens or symbols that we take. So what we can loop is while the line is not at its end, like I said, we're looping until the end of the line. While the line's not ended, and the string's length is equal to num. So notice I'm negating this whole condition. This is equivalent to saying while not line at end and the string length is not num. In fact, why don't I just apply De Morgan's law? I don't know why I thought that was more readable. But basically, we're looping while we're not at the end, and the number of characters that you have currently, which is represented by string length, is not num, which is the number of characters you want. So suppose we're taking characters and we take 3 characters and we called take 3, then string.length will be equal to num and we'll stop looping. Now we can reference the current character here, the next char. In this case, I'm going to keep the negation of the whole thing. We have 2 conditions here. We have the these and we have the until. So we want to break essentially if one of these conditions is met. Either, let's see, if these is empty or the character's in these, then we don't break. So we have to negate the whole thing. You could, of course, apply De Morgan's law again and say these is not empty and char is not in these. If you want to negate an in Kotlin, you can put it there. You don't have to use parentheses. So basically, so long as the character is in our list of these, or we didn't provide a list of these, we don't break. But we do want to break if that isn't the case, or if char is in until. Because we're looping until the char is in that list, so once it is, we break. If neither of those conditions are met, then we can continue to grab characters, and we can just add our char to the string, and then we can call step position in the line. And then we just do that loop, and at the end, what we have to do is we have to say, if we're at the end of the line, we've read through the whole thing, then we should read another line. And of course, if we're at the end of the file, then we're not going to do that because we're just at the end of file. And we'll return the string. So if you call take after you've reached the end of the file, it doesn't matter, which is why we have this condition at the top. But otherwise, it's just going to read things, and it automatically will read the next line for you. You don't have to worry about it. It's just going to construct the next line. And you can just keep calling .next string, and .take on this thing, and like you're fine. In fact, readline is an example of something that should probably be private. Like you just don't need to worry about that, at least most of the time. And that's our source file. My throat is actually kind of sore from all this talking. So I think, wow, I really am splitting this out into multiple episodes. I could have rushed through it, but I think this is actually going to be better. I think this is going to be a better tutorial series than the first one. In the next episode, then, we'll make our token class, and we'll actually make the lexer class finally. But we have a lot of the tools that we're going to need. You see, I'm abstracting a lot of this away into the source line and source file. And I must say, I really do like this design of this lexer. If you can like understand what I'm trying to convey, how it works, without actually using the lexer yet, then hopefully you agree and think it's a pretty good design. I'm sure it can be improved, but I like it. It's taken me a lot of time to sort of hammer it down into this shape, but I think it's a pretty good shape and it's super useful, especially this next string function. That's really new, but it's super useful. So anyway, that's probably enough rambling. Next episode, tokens and lexer. I'll see you guys then.